Hi guys, this is going to be a video about calculating the enthalpy of reaction from bond enthalpies. And so, if we consider a reaction, well, there's going to be a lot of bonds broken and bonds formed whenever you are looking at stuff, right? So for example, if I had the reaction C3H8 plus F2 reacting to form C3H7F plus HF, and it's important that all of these are gases. Well, we can take a look at this reaction in terms of its bonds, okay? C3H8 looks something like this, where you have a straight carbon chain with 8 hydrogens coming out of it. F2 looks like this. You have a single bond, and then you have fluorine, just connected like so. C3H7F looks very similar to this molecule is called propane, but one of the hydrogens has been replaced with a fluorine. So we have 7 hydrogens, but the 8th bond there is going to be replaced with a fluorine. And we have a hydrogen connected to a fluorine over here. Okay, so if you took a close look at what has changed, well, what has changed is there's a carbon-hydrogen bond here. There's a fluorine-fluorine bond on the reaction, and if you compare it to the products, those bonds aren't there anymore. Okay, it's been replaced with a carbon-fluorine and a hydrogen-fluorine. Okay, so when we're taking a look at these enthalpies of reactions, we want to compare, all right, what bonds have changed in the reaction? Okay, so in order to get this reaction to happen, we have to break these bonds, and then we have to form these bonds. Okay, in some way, we have to break these bonds and then form those bonds. Okay, and we won't consider how this actually happens, but we can calculate what kinds of energies are involved. So we can look up these values to see how strong these bonds are. Remember, a bond is simply just 2 electrons occupying a lower energy state, right? That's what makes the bond there. And so when you break a bond, what you're doing is you're adding electrons to that bond. Sorry, you're adding energy to that bond. And so you're forcing the electrons out of the bond, and thus you break it, right? It's the same thing when you form a bond, but the opposite, right? You release energy in order for those electrons to occupy the bond. Okay. So we can look up these values, and if we do look up these values, the value of a carbon-hydrogen bond, right? How much energy is in that? Well, you have 413 kilojoules per mole. Okay, so for a mole of carbon-hydrogen bonds, that's 413 kilojoules. Okay, for a fluorine-fluorine bond, if you look that up, that's 154 kilojoules per mole. For a carbon-fluorine bond, if you look that up, that's 485 kilojoules per mole, so it's a pretty strong bond there. And for HF, right, for a hydrogen-fluorine bond, that's 565 kilojoules per mole, so very, very strong. Okay. So how do we calculate the enthalpy of reaction then? Well, if it takes energy to break bonds, that means these values are positive. If we then have to release energy in order to form it, that means these values are negative. And so the sum of all of these together will make up your enthalpy of reaction. So your enthalpy of reaction is going to be, well, you're going to have your carbon-hydrogen bond, your fluorine-fluorine bond, those are going to be broken. And then you're going to subtract off a carbon-fluorine And I'm going to put these in parentheses so I don't confuse them. And you're going to subtract off a hydrogen fluorine. Okay? So to break a bond, it takes energy, so you add it, and then to break or form a bond, you release energy, so subtract. So you just plug in the values, 413 plus 154 minus 485 minus 565, and we got to remember these are all kilojoule per mole values. And so you do the math, right? Get my calculator. So that's 413 plus 154 minus 485 minus 565. And that's going to be equal to negative 483 kilojoules per mole. Okay. And that'll be the enthalpy of reaction. So when this reaction happens, it will release 483 kilojoules per mole. All right. Other than that, should be good. Be careful with your calculations. Have a nice day, everyone.